In modern aerial warfare, invisibility is power. And no aircraft embodies that idea better than the F-35 Lightning II, a fifth-generation stealth fighter designed to evade even the most advanced radar systems on Earth. But what happens when that invisibility is challenged? Today, we dive into a high-stakes technological showdown, Iran's Ghadir radar versus the stealth capabilities of the F-35. Can Iran's radar systems actually detect and even lock on to one of the most advanced jets ever built? To understand the stakes, we need to start with stealth itself. The F-35's design is optimized to defeat conventional radar. Its angular shape, radar-absorbent materials, and internal weapon bays all work together to reduce its radar cross-section. To most modern radar systems operating in higher frequency bands like X-band, the F-35 can appear as small as a bird or even vanish entirely. But stealth isn't invisibility, it's optimization. And that's where Iran's approach becomes interesting. Enter the Ghadir radar, an Iranian long-range radar system, reportedly capable of detecting targets up to 100 kilometers away. Unlike typical fire control radars, Ghadir operates in the VHF band, which uses much longer wavelengths. Why does that matter? Because long wavelengths interact differently with stealth aircraft. Instead of being absorbed or deflected, these waves can resonate with larger parts of the aircraft structure like wings and fuselage, making stealth shaping less effective. In theory, this gives VHF radars like Ghadir an edge, but detection is only part of the equation. Tracking and targeting a stealth aircraft requires far more precision. And this is where things get complicated. The Ghadir radar is believed to function as an early warning system, not a fire control radar. That means while it may detect something unusual in the sky, it doesn't necessarily have the resolution to provide accurate targeting data for missiles. In other words, it might see the F-35, but not clearly enough to shoot it down. So how does Iran attempt to close that gap? Through networked air defense. Iran has invested heavily in layered defense systems, combining different radar types across multiple frequency bands. VHF radars like Ghadir can provide long-range detection, while higher frequency radars attempt to refine the target's position. Systems like the Bavar 373 are designed to integrate this data, potentially enabling engagement against stealth aircraft. This multi-layered approach mirrors strategies used by other countries trying to counter stealth technology. Now let's talk about AESA Active Electronically Scanned Array. While Iran claims advancements in AESA radar technology, it's important to note that true AESA systems require extremely sophisticated electronics, signal processing, and manufacturing precision. The F-35 itself carries one of the most advanced AESA radars ever built, the ANAPG-81 radar. This radar not only detects threats, but also performs electronic warfare, jamming, and data fusion in real time. That gives the F-35 a massive advantage, not just in stealth but in awareness. So can Ghadir lock onto an F-35? Short answer, unlikely, at least on its own. VHF radars are excellent for detection, especially against stealth aircraft. But they lack the precision needed for missile guidance. Locking onto a target requires high-resolution tracking, typically done with higher-frequency radars that stealth aircraft are specifically designed to evade. However, that doesn't mean Iran's system is ineffective. Far from it. Even detecting a stealth aircraft at long range changes the battlefield. It forces pilots to adjust routes, increases uncertainty, and can trigger defensive responses. In military strategy, that alone can be valuable. This is what analysts often call a deterrent effect. So what's the final verdict? Iran's Ghadir radar likely cannot independently track and lock onto an F-35 with high accuracy. But as part of a broader integrated air defense network, it could play a meaningful role in countering stealth operations, at least at the detection level. And in modern warfare, even partial visibility can shift the balance. Because the real battle isn't just about seeing or not seeing. It's about who sees first, who understands faster, and who acts before the other even knows they've been detected. As stealth technology evolves, so do the systems designed to defeat it. The question isn't whether stealth can be broken, it's how long it can stay ahead.